Welcome to Mr. Shaw's videos again. We're talking about naming and writing formulas for acids and bases today as part of section 9.4. So your objectives. The first one is to determine the name and formula for an acid, and then to determine the name and formula for a base. So some common household acids include something like lemon juice. There's some acid in there. Different types of other household products like vinegar is another common household acid. And acids are, as you know, below 7 on the pH scale. So you've learned about the pH scale before. Acids are below, and things that are basic are above 7. So acidic is below, and basic is above. But what is an acid specifically? Over here we have our sign for acids. If you drop an acid, you need to be really careful in the lab because sometimes you work with very concentrated acid that can really be harmful to yourself. So you use that sign to indicate acid. An acid is a chemical compound that contains one or more hydrogen atoms and produces hydrogen ions when dissolved in water. So that's the key idea here. Not just that it has hydrogen, but that it makes hydrogen ions when you combine it with water or when you dissolve it with water. An anion is basically combined with as many hydrogen atoms needed to make the molecule neutral. And that's how an acid is formed. Okay. The chemical formula involved with acids is usually represented as HNX, where X equals the anion, whatever it may be, and then N equals the number of hydrogen to balance out the anion. So this is our formula that we often use to represent a acid. So given a formula for an acid, how do we actually go about naming it? There are three sort of situations involved with naming acids. The first one involves anions whose endings are IDE, so they're monatomic, they're not polyatomic ions. The acid name would then begin with hydro, and the stem has a suffix ic, and then we end it with the word acid. So your example would be HCl. HCl has no polyatomic ion, it's just the Cl anion, which ends in IDE, chloride. So we're going to change it to chloric, and we have to put hydro in front of it. So hydrochloric acid. That would be the name for HCl. Your second situation is when the anion ends in ITE. So we have a polyatomic ion ending in ITE. The acid name is the stem of the anion with the suffix OUS followed by the word acid. So if you had HNO2, nitrite is NO2, okay? You would then not use hydro. We don't have to use hydro because it's a polyatomic ion. We just change the nitrite to nitrous, and we add the word acid. So nitrous acid. Okay. And your third situation is when the anion name ends in ATE, so it's another polyatomic. The acid name is the stem of the anion with the ic suffix IC, followed by the word acid. Again, no hydro is needed because it's a polyatomic. So if you had HNO3, nitrate is NO3. And we change it to nitric or nitric acid. And again, no hydro is needed because it's not a polyatomic ion. So how do we write formulas for acids? So going from the name to the formula. To write the formula for an acid, use the rule for writing the name, but in reverse. Then balance the ionic charges just like you would for any ionic compound. So if I gave you hydrobromic acid, okay, since it has hydro, you know it's going to be a monatomic ion, so not polyatomic. The bromic tells you it's going to be bromine, the element bromine, and you have to add hydrogen to any acid. So HBr, Br is -1, H is going to form a +1 charge, so when you swap and drop, you get HBr. Let's say you had sulfuric acid, one of my favorites. The ic tells you it's an ATE ending, okay? So there's no hydro here, you know it's going to be a polyatomic ion. So you have H with the +1 charge. We change the IC-ic ending to an ATE, and so it's going to be sulfate, which is SO4 -2. We swap the charges and drop the numbers to subscripts, so we get H2SO4. So those are some examples for writing formulas for acids and then using the names to find them. We have some common strong acids. They're strong, like shown here. They're very concentrated or can be very strong. They're hydroiodic, hydrobromic acid, perchloric acid, nitric acid, sulfuric acid, chloric acid, and hydrochloric acid. So just some common strong acids. So what about the other side? What about bases? Why does barium selenium love Meghan Trainor? Because he's all about that base. Just like NaOH is a base. What is a base? How do we name them? And how do we write their formulas? Base is generally an ionic compound that produces hydroxide ions. Hydroxide is a polyatomic OH -1. And that happens when it's dissolved in water. They are named just like ionic compounds. The metals come first, and then the non-metal ion, and then you balance the charges as you would for writing formulas. So ionic compounds and naming bases are very similar in that they're exactly the same. Sorry about that. They're exactly the same. You name them exactly the same way. So if you have any questions on acids and bases, we'll talk more about it tomorrow. Other than that, have a great night.